Hey everybody, I am Miss Gamble, and I'm going to be doing the lecture videos for Unit 2, which is all about trig graphs. So today we're going to learn our 6 parent trig graphs, and before we actually put y equals sign on our coordinate plane, on our x and y axis here, let's take a look at how we go from the unit circle to the coordinate plane. So as we go around the circle here, right now you can see our dot is at 0, 0. It's going to go counterclockwise around the circle just like we would go, and it's going to put those points onto our coordinate plane. Okay, so we're going to start here. Pi over 2, about to be a pi. There's 3 pi over 2, and then 2 pi. And so if we take all those points off of our unit circle, we see that we actually get a wave, a sine wave. So let's go back now and let's talk about how do we put those points on the units or on the coordinate plane, excuse me. So starting with 0, 0, we're going to just focus on labeling our axes, okay, our main points. So we would have pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to go one time around the circle here, and we know the greatest that sign can be is 1. The least is -1. Okay, so when we are at the point 0, 0, right, on our unit circle, that point would be there. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, sine is -1. And at 2 pi, sine is back to 0. So you see we have our sine wave. Now, I'm going to put arrows on here because we know also that we can keep going and making more and more revolutions with coterminal angles, and so technically this graph keeps going and going. So here is an example, if we kept it going, of a sine wave. Okay, the domain is all reals. It never stops. It keeps going and going. We can keep rotating around the circle over and over again, and we're going to keep getting those same values because of coterminal angles. So a graph like this is what we call a periodic function, right? It's a function that repeats over and over again. One period of the function, we call this sometimes the fundamental period of the function, is the minimum interval in which a complete function occurs. So think about that. For sine, okay, let's go back and look at this graph right here. For sine, we go from 0, and this kind of went off a little bit, but over here to 2 pi, and that is a complete curve. Well, if I started back here at -2 pi, put this one in a different color, and I went this way to 0, well, that is also 2 pi, right? From -2 pi to 0 is 2 pi, and I see that same complete curve. That's what we call it, the period of the function, all right? It's the minimum interval in which we see a complete rotation, a complete function, if you will. After that, it would just repeat itself again. Now, the midline is the middle of our graph, vertically speaking, and the amplitude, which is the distance from the midline to the maximum or the minimum, those are both things we're going to look at more tomorrow, okay? But also features we want to think about on all of the graphs is the midline, because it's going to be real important to us as we graph it. All right, let's move on to our next one, which is cosine. So again, we are going to label our axes using each 90-degree or pi over 2 mark. Cosine also can only be a maximum of 1 and a minimum of -1. Okay. However, at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1. So this one looks like this, but be careful with your arrows here because technically it's going to start to come back down. Okay, so if we are looking at one that's already been done for us, here's a cosine curve. So looking at this, you're like, well, that looks exactly like a sine curve, and that's correct to an extent, right? If we're looking at 0 here, well, sine and cosine have different values. But looking at the coordinate plane as a whole, we can see, yeah, they do. They look the same. A sine and cosine wave, they look very, very similar. And that is because, think about your unit circle, sine and cosine have all the same values. So if we look at this one, starting at 0 and going from 2 pi like we just showed, that's one period. That's a complete cosine curve. Well, if I went backwards to negative 2 pi, there is another complete cosine curve. Okay, so add a little bit to both of these now that we've seen them both. I'm going to go back up here to sine for a second. If I asked you, what is the period? How long does it take to see one complete curve? It is 2 pi. Okay, 2 pi. Now, our domain here is all reals, right, from negative infinity to infinity. And our range, even though we see these arrows, those arrows just are showing our wave is going to keep going. Technically, -1 to 1, right? That's as far as we can go. Now, we're not going to ask you the domain, but the range definitely is something we could possibly ask you. Okay? And then what we see for cosine, right, looking at our cosine curve, is again, it's the same thing. To see one complete curve, the period, we have an interval of 2 pi. The domain here is also all reals. And then the range is -1 to 1. All right, so let's move on. And remember I said sine and cosine are the ones we're going to look at the most, but we still want to know what these others look like. So let's look at tangent here. Now, tangent is a little bit different. So I'm going to graph tangent. I'm actually going to start back here at negative pi over 2. And then I'm going to plot negative pi over 4, 0, pi over 4, and pi over 2. And I'm choosing these guys just so I can give you a better picture of what's happening. Okay? So at 0, tangent is 0. At pi over 4, tangent is 1. And at pi over 2, tangent is undefined, which on the graph means we have a vertical asymptote. Okay, now if we go the other direction, the tangent at negative pi over 4. Negative pi over 4 is the same thing as 7 pi over 4, and the tangent is -1. That is a negative. And then the tangent at negative pi over 2, same thing as 3 pi over 2, is undefined, just like pi over 2, and so we have a vertical asymptote. So what we have here is something that looks similar to what a cubic function would look like. Not, but similar if you want to think of it that way. Okay? But look at this. We went from negative pi over 2 to positive pi over 2. That is an interval of only 1 pi, and this is a complete tangent curve. Okay? How do I know? Well, if I went on, well, didn't put it there. If I went on, sorry about that, to 3 pi over 4, what is the tangent at 3 pi over 4? It's -1. And then if we went on to 3 pi over 2, excuse me, pi, got a little ahead of myself there. If we went on to pi, what is the tangent? 0. And what happens is it was just going to repeat itself. So different than sine and cosine, tangent has a period of pi. That's how long it takes to see one complete curve. Now, would not ask you the domain for this because we'd have to write that a special way because we have so many different asymptotes. But our range here, we do want to understand, is negative infinity to infinity. Okay? Now, sine and cosine, like I said, are the most important. So the other ones I just am going to talk about, and they're ones that we need to know them, guys. We need to be able to recognize them, and we need to be able to evaluate if I ask you what a certain point on the curve is, which we'll get to with our next lesson. All right, here's our cotangent graph. So if you notice on cotangent, it looks like it's kind of backwards from tangent. kind of makes sense, but not like sine and cosine where they look exactly the same, only like they've been shifted on the coordinate plane. So on this one, we have an asymptote at 0 and then at pi. Okay, and then technically we went backwards here. We also have one at negative pi. So this one, our asymptotes are in different places, which makes sense because tangent and cotangent are undefined at different places. What's important to recognize here is a complete curve, a complete cotangent curve, that's going to be one arc, right? After that, it's just a repetition of itself, goes from 0 to pi. So just like tangent, the period of cotangent is pi. And again, I wouldn't ask you about the domain, but we need to know that the range is all reals. Okay? All right. Secant and cosecant are our other two. So let's look at cosecant first. Okay, so cosecant, make this a little bit bigger for us, also has asymptotes, right? Remember from our unit circle, there are places where the cosecant is undefined. It is undefined along the y-axis here, right? And then also at pi, and then 2 pi. We could work backwards too if we wanted to. But a complete cosecant curve is a curve here, which technically keeps going up, and then a curve here. After that, everything's just repetition, but you have to have one that's going up and one that's going down. That takes us from 0 to 2 pi. So just like cosine and sine, the period for this is 2 pi. Okay, which makes sense because cosecant is the reciprocal of sine. It makes sense that they would have the same period. Now, just like tangent and cotangent, we're not going to ask you the domain for these because, again, you have those asymptotes along your x values. Excuse me. So the domain would be a little more challenging to write. But we are going to ask about the range at times. And so that one, if we look at it, we're going to go from negative infinity to negative 1. Okay? We have the point negative 1 here. And that's included. And then it picks back up here, right, at positive 1 and goes to infinity. All right, last graph is the graph of secant. Should look similar to cosecant, and it does, but our asymptotes are in different places. So for secant, let's look at this one here in the middle. We have an asymptote at negative pi over 2, pi over 2, and then 3 pi over 2. And again, we would have more if we keep repeating our pattern, but we can see here's one curve, right, going up, and then we have another one that is going down. That's a complete curve, or complete function, right? Period of a function. After that, they're going to keep repeating. So the period from this one, we go from negative pi over 2 to 3 pi over 2. Well, that is an interval of 2 pi. So the period for secant, just like cosecant, sine and cosine, is 2 pi. And we're just going to make sure we know how to find the range. It's negative infinity to negative 1, and it's 1 to infinity. Okay? And if we're talking about writing the domain on a lot of these, you'll see it sometimes. They write them in different ways depending on the author of a book. But you're basically saying, okay, the domain is all reals except for negative pi, x cannot equal negative pi over 2, plus every pi, right? If we added pi to negative pi over 2, we'd be at pi over 2. If I add pi to that, I'm going to be at 3 pi over 2. So that's how we would write it, so you can see that sometimes written. But again, we're not going to worry about that. And our focus this unit is now going to be, hey, we need to memorize and know these 6 trig graphs, but really what's our main focus is sine and cosine. We're now going to start taking those graphs with tomorrow's lesson, and we're going to start stretching them, shrinking them, reflecting them, and shifting them. Okay? But today, we need to know these graphs. We need to be able to recognize them, and you need to be able to put sine and cosine down on a piece of paper very quickly. All right? So, homework tonight, make sure you know these graphs.